This is problem 7-53 from section 7.1.4, part 1, homework. It says, use the Pythagorean identity to find the exact coordinates of a point on the unit circle that has sine of theta equals 1, 4. So I'm going to draw in my circle what that angle might be. This angle. I'm going to have to find the coordinate of this right here. Let's just call it P, maybe, point P. And I know the sine of theta is my height. So I know this height right here is worth 1, 4. We talked the other day about what does it mean to the exact coordinates. We figured out, we introduced cosine of theta is really my x value, and then my y value, or the height, was sine of theta, which we've been doing that for a couple days now with their screamer. So I'm finding the coordinates. I already know this coordinate is given to me. I really need to find the cosine of theta, and I'm going to leave that in as exact as possible, so no decimals. I'm going to keep square root signs in my answer. And it says to use the Pythagorean identity, which is something we also kind of talked about previously in the last section. So Pythagorean identity is kind of using the Pythagorean theorem, but instead of x's and y's or a's and b's, we're going to use cosine of theta and sine of theta. So let's write the Pythagorean identity. Write that here. Is going to be cosine of theta squared, just like if you had called it side A squared, plus I'm going to call side B is going to be called sine of theta, equals side C, which is my radius, which in this case happens to always be a 1, and 1 squared is 1, so I'm just going to leave that as the 1 right there. So we're going to plug in what we know right now. We again said we need to find cosine of theta, and we're going to use this identity to help us find that. So cosine squared plus sine of theta. Now I know this. I know this is 1, 4 squared equals 1. Okay, so we're going to kind of find our missing variables here. So again, it says in exact form, so we're not going to turn this 1/4 into 0.25 and square it and round the decimal on our calculator. We're going to leave it as a fraction, because you love fractions so much, but they give us exact answers. So I'm going to have 1/4 squared. So 1 squared gives me a 1, 4 squared gives me a 16, equals 1. How to get cosine of theta squared by itself? I subtract 1/16 from both sides. Okay, so I can really turn this 1 into 16 over 16. So hopefully that'll help. If I take 16 minus 1, this is going to be 15 16ths left over here. Again, we're leaving it in fractions. We want the most exact answer for this problem. So to get rid of my squared right here, I'm going to take the square root of both sides. So that will cancel out, leaving the cosine of theta. I don't even care what the angle is. It only asks me for the coordinates. So it really doesn't matter what the angle is. So cosine squared of 15 over 16. Now, I don't know the square root of 15. I'm not going to type that in my calculator and round it. Again, I don't want to round. But I do know the square root of 16. So I'm going to change this to say cosine of theta is going to equal the square root of 15 over square root of 16 is worth 4. So that is my x coordinate of, if we're calling this point P, that would be the x coordinate of point P. So we're going to put our things in place. We know this square root of 15 over 4 is the x coordinate, or the horizontal distance, and they gave us sine of theta, which was 1, 4. So remember we said way up at the top here, my coordinates was supposed to be cosine of theta and then sine of theta. I don't even need to know the angle. I just need to know the horizontal distance and the vertical distance. So here is my final answer, the coordinates, and then just the sine.